Hello everyone. Greetings and welcome to our webinar. It brings me great pleasure to have you all in attendance today as we explore an insightful program. Our speaker for this event is one of our well-experienced engineer Arman, who has been an integral part of KubeDB team for an extended period of time. As we commence, I'd like to highlight the importance of your involvement and contribution to this webinar. If you have any questions or queries, please don't hesitate to raise them in the Zoom chat and we will answer them during the QA segment. Without any further delay, let's proceed the program. I'd like to hand over to our speaker Arman, who will provide valuable insights regarding the topic. Over to you, Arman.
Hello, good peoples. Welcome to our webinar on provisioning and managing MariaDB Standard Replication with KubeDB using MariaDB MaxScale Proxy server. I am thrilled to have you all here today to explore how we can simplify and enhance database management in Kubernetes environment using KubeDB. Here I am Sheikh Ali Arman with you. Okay. Without any further delay, let's dive right into the topic. Let me share my screen. Okay. Okay, my screen share is working, right?
Yeah, it's working.
Okay.
I can fully share the slide.
Okay. First, let's take a look at our table of contents, which is going to be discussed today. We'll cover what MariaDB replication is, then the basic of MariaDB standard replication, how KubeDB provisioning the MariaDB standard replication using KubeDB. Then finally, we will wrap up with a live demo to bring it all together. My goal is to make this practical and clear, so you can walk away and with a solid understanding of how those tools work together. Okay, let's begin with MariaDB MaxScale. Okay, so what is MariaDB MaxScale? Think of it as a powerful proxy server that sits between your application and your MariaDB databases. It's designed to make your database setup smarter and more resilient. MaxScale act as a load balancer, distributing traffic across your databases to optimize performance. It is provide high availability feature, ensuring your system stays up even if a server goes down. One of its standout capabilities is read-write splitting. MaxScale can automatically send the write queries to the master database and the read queries to the celebs. Plus, it supports uh, advanced replication topologies such as multi-master architecture. In production, you need MariaDB Enterprise license to use this MaxScale. Okay, next. Okay, let's talk about MariaDB standard replication. This MariaDB standard replication is the backbone of many high availability database setups. MariaDB standard replication uses as an active passive single master architecture. In this picture, this is a MariaDB standard replication with one primary server which is called master, and some replica databases called celebs. Celeb replica asynchronously copy data from the master. Those replicas handle read operation, which helps distribute the load and improve performance. MariaDB standard replication is perfect for for scenarios like where you need redundancy and want to offload read heavy workloads. The main reason behind using MaxScale in this MariaDB standard replication is MariaDB standard replication doesn't have any built-in automatic failover support. That's why the automatic failover is maintained by the MaxScale proxy server. Uh, okay, now how do we manage all this in Kubernetes environment? That's where KubeDB comes in. KubeDB is a powerful tool for provisioning and managing databases in Kubernetes. It simplifies the process of setting up and maintaining MariaDB instance in KubeDB. Previously in KubeDB, we have only Galera cluster topology, which is multi-master architecture. But now we are supporting MariaDB standard replication. And the provisioning process is same as MariaDB Galera cluster. Here we additionally we have added a MaxScale proxy server. The the provisioning process is simple. KubeDB operator washing the MariaDB CR. Then it creates a page set for MaxScale proxy server and one page set for MariaDB standard replication server, and some other resources such as secret service PDB binding PVGs. Okay. You can install KubeDB by simply running this helm command, and you will need a license to install the KubeDB. You can get the license from our KubeDB website, which is kubedb.com. Okay, at this point, you are probably thinking this sounds great, but I can see in action. Okay, absolutely. Then that's bring us to our live demo. I am going to walk you through a real-world example of provisioning a MariaDB cluster with a standard replication using KubeDB and MaxScale, of course. You will see how those tools work together to create a robust, scalable MariaDB database setups in Kubernetes. Okay, let's switch to the demo environment now. Okay, so this is a sample YAML file of MariaDB standard replication topology. Here, the replica theory means we will have theory node of MariaDB standard replication, and we mentioned the topology mode is MariaDB replication. And in the MaxScale config section, we will set up the MaxScale replica theory means we will need 3 replica, and enable UI true means we will have a integrated UI of MaxScale proxy server. And those are the common field. The storage type durable means you are persistent the storage. Okay. Okay, then let's deploy this YAML. Okay, let's watch the resource MariaDB custom resource, then page set deployment, pod secret service, and PVC. We are deploying the resource in demo namespace. So let's get those resource. So our MariaDB is provisioning state, and it creates the MariaDB server page set and one page set for the MaxScale proxy server. Here we'll see the ports, 3 for MariaDB database and 3 for proxy server. This is the secret for the MariaDB database, what secret, and service. This is the primary service for the MariaDB database. And MDMX, this is the primary service for the MaxScale proxy server. And MX, this is the governing service for proxy server, MaxScale proxy server. And this is the standby service for the MariaDB databases. Okay. Okay, we can see the state of the server by executing the proxy server. Okay, let's do that. Okay. Here our primary server is MD port 0 and the other two is sleep. All are running and up and running. Okay. Okay, then let's the proxy. Okay, to test the proxy server is working, let's deploy deployment of Ubuntu base image. Okay, then this is the YAML of a sample deployment. The image is Ubuntu. Okay, let's deploy it. We'll test the MaxScale proxy through the Ubuntu image. We'll set up the Ubuntu server and install there the MariaDB client. Okay, let's exit into the Ubuntu server and set up the MariaDB client. Let's update the apt. Okay, then update. Let's get the secret, user and the password of MariaDB database. Let's get the secret of this MD auth secret. Okay, let's see. Okay, this is the password for our root user. Okay, let's connect through the MaxScale service MDMX. Let's put the password from here. Okay, MD port. Okay, that's look good. Okay, we connect to the MariaDB server. Okay, let's create a user. The root user is a super privileged user, and it can write on a read-only database. And if you write a slave replica with a read-only database, you will get the binary log conflicting issue. And we are not doing any magic to do the auto health check in this issue. You need to manually fix this scenario. So that's why we are recommending to use non-root user in production grade users. So we are creating a simple test user, and we will test our MaxScale proxy server and MariaDB database with this test user. Okay, let's create the test user. Okay, I have the command here. let's get and put okay, let's create the user name test user and the password is test password. Okay, now grant some permission, flash the privilege and quite uh, okay. Okay, now connect the MariaDB database through Proxy scale using this test user. Okay, so this is the Proxy MaxScale Proxy service. Okay, let's connect. So we have connected successfully to the MariaDB database. Okay, now let's check the read query. We will check the write and read splitting. So first check the read query. Here the data can be read from any of those three server, and the write query will only happen to the port 0, which is the master. Okay, okay, now let's create a database to check the read query. Okay, okay, we'll create the database later, no problem. Let's check the read query. So simply I am selecting the now means the date time of current time, and the host name means the which host the query is running. So let's run this query. So the result is time. So this is the current time, and the host md0 means the this query is running on the server md0. Okay, now let's run this query several times, and you will see the previous server was md0, but the current one is md2. Let's run this again. Okay, this means the read query is running in md0, and you will load balance sometimes in md1 and sometimes in md0. So it's distribute the read query to all those three servers. Okay, now let's check the write query. So we have created a test DB. Now create a table on the test DB. Now create a table and insert some data. So this is a write query. I am inserting data on with the containing the this is just ID and the host name. Host name means the which host this query is processing. So let's run the query. Okay, several time. Okay, let's check the database. Okay, okay, you will see the host name is always md0, means the write query is only running md0, which is the master port. Okay, so our read write splitting is working. Okay, now let's check the automatic failover. So here now currently the port 0 is the master. Let's restart the port 0 and see the automatic failover is working or not. Okay, okay, then let's delete the port 0. Keep delete and demo. So let's delete the port. Okay, so the our port 0 is down now, and this is running, and this syllab is running. Okay, it's switch the master. The port 1 is master now, and the database status is critical. When this pod get up, it will join the cluster and get the status like slave and running, because it will join the cluster as slave replica. Okay, let's wait and see it's join or not. Okay, the pod 0 is up and running and it joined the cluster as the slave. Okay, so our automatic failover is working and the MaxScale proxy server is also working. Okay, we have enabled the UI of MaxScale proxy server. Okay, let's test the proxy server UI. Let's port forward the proxy server UI. Cartel forward. So this is port forward, and the server is running on this port. Okay, let's check this. Okay, this is running. So the default user is admin and the default password is MariaDB. Okay, now sign in. So it's signing successfully. You will see a dashboard like this where the status of the server are showing up here. So here MD0 is slave and running, MD1 is master, and MD2 is slave and running. Okay, this looks good. Okay, you will see here a menu bar where you can check the monitoring stuff. Also, you can change the password of the proxy server. Just put the new password and you update the password, it will change the password. Okay, you can visit and check this UI. This is good. Okay, okay, now now we are back. I hope that's demo gave you a clear picture of how straightforward it is to manage MariaDB replication with KubeDB and MaxScale. To recap, we covered the MaxScale as a proxy server that boosts performance and reliability. MariaDB Standard Replication for scalable active passive setup, and KubeDB as a tool that tries it all together in Kubernetes. Okay, let's before we wrap up, I would love to hear your questions. If you have any question regarding this session, you can ask.
So hello audiences, if you have any queries regarding MaxScale or MariaDB replication or maybe KubeDB, you can ask that in the Zoom chat or you can raise your voice. We are available here to answer. So I guess there is no question at this point. So thank you, Arman, for this amazing hands-on demo-based like webinar. And also thank you all for your participation. We look forward to your presence in our future sessions. Visit our website appscode.com/webinar to check the schedule and register for upcoming events. Wishing you all a very great day. Bye bye.
Okay, thank you all. Have a great day.